So this video is going to deal with factoring quadratics, and what we're going to talk about in this video is two very important pieces of information. First and foremost, we're going to learn how to factor a quadratic, which is based off of the steps that I gave you during class today. But we're also going to talk about what a factor actually is and what it means in terms of my quadratic equation. So when I'm talking about factors, ultimately what I'm going to be finding is a key feature on my parabola that we've talked about in class before. The factors are going to be helpful because they are going to help us find the zeros or the solutions or the roots for the quadratic parabola without ever seeing the graph itself. Now, I'm going to tell you this. Factoring is for very special types of quadratic functions that I can actually break down. And I'm going to show you as we work through what I'm actually breaking it down into. But not every quadratic equation that we will come across can be factored. That's okay because I have another solution for that we'll get to later. So factoring though, what I'm going to start with is a quadratic equation. And based on the steps that I gave you in class, which are also linked at the bottom of the video, you can take this, and the first thing I need to do is figure out if I have a greatest common factor. So I'm going to look at A, B, and C, which we've talked about before. A, B, and C are the constants and the coefficients in my equation. So 2, 5, and -7, they don't have any greatest common factor. There's no number that I could divide evenly out of all of them. So I'm going to start by making myself a t-chart. On the left-hand side, I'm going to think of what A times C turns out to be, and on the right, I'm going to deal with the value of B. Ultimately, I'm headed towards the box method, which is what we used when we multiplied binomials. So A times C, 5 times -7, gets me -35, and then my B value is 2. From here, my goal is to find factors of -35 that add to give me +2. If I did -7 multiplied by 5, this would end up adding to make -2. But if I do +7 times -5, that will get me to +2. So these two numbers are what I care about when I head to the box. Now, if you remember back to when we were doing operations with polynomials, we got to a point when we multiplied from the outside in where I could combine these two like terms to get my value of B. I'm working backwards though, because I have my value of B, and my goal is to figure out what multiplied together to get me these terms that got us this final 2x. So these numbers that we found are what's going to go in this diagonal. So I'll have +7 and -5, and it doesn't matter if you have these flip-flopped in your box. It's okay this way, or if you had -5 down here. It's totally fine. But because I'm aiming to get x, both of these need to have that variable with them. So this is what we would have ended with after we multiplied from the outside in to get our final trinomial. So our goal now is to work from the inside out to find out what we multiplied to get 5x squared and -5x and so on. So I'm going to do, excuse me, each column and each row with a greatest common factor. My goal is thinking, okay, what is the most number of variables I can pull out? What's the highest coefficient I can pull out to get those greatest common factors, which are going to build our binomials. So here, -5x squared and -5x, they both have a 5 in common, and they both have an x in common. I'm not going to pull out the negative sign, because if I multiplied something here, then this would end up being negative. Across this row, I can only take a 7 out of each of those. And again, I'm not going to make this one negative, because they both are not negative in this case. Straight down, coefficients don't have anything in common, but they both have an x that I could take out. Coefficient-wise in this column, 5 and 7 don't have anything in common, but they are both negative, so I can show that with a -1 as my common factor. If you need to double check yourself to make sure you've done this correctly, you can go back to what we did before and multiply from the outside in to make sure that what you have as your binomials will multiply to get you all 4 pieces inside the box. And now I'm going to work backwards again, and my factors are actually going to be these binomials that we had started with before. Now we're coming back as my answer when I factor. So I'll have 5x plus 7 and x minus 1. So I'm going to let you take a moment and process, see what happened. And I will tell you that from here on out, I'm not done yet, because my goal is to find my zeros. So I'm going to switch back to the parabola graph that I had on the last slide. My goal is to find the zeros. This graph is not the graph for the equation I'm talking about, but in this case I have 2 solutions, both of which have a value of y that is 0. That's why we call them a 0. So here I need to show what happens when y ends up being 0. So I'm going to take my equation right now and I'm going to set it equal to 0. So now I have to think, okay, this is multiplication. So 2 things are being multiplied together and ending up equaling 0. So what would I have to multiply with in order to get it equal to 0? One of these pieces has to end up being 0 in order for me to end up having this whole multiplication turn out to be 0. And the only way that that's going to happen is if I find a value of x that makes 5x plus 7 end up being 0, or x minus 1 ending up as 0. So what I do, just to keep everything separate, is I'm going to split these right down the factors. And I'm going to say, okay, let's find out what would happen if 5x plus 7 is the factor that ended up being 0. If I work through and get x by itself, that would tell me that the value of x that would make this factor equal to 0 is -7/5. And I'm going to do the same thing over here. What if x minus 1 is the factor that ended up being 0? This would tell me that the value of x equals 1 would give me a 0. So what I've done is I used my factoring to get binomials that multiplied together to get me back to my original equation, and then used those factors to find out the 2 values of x that would give me my x-intercepts, or my solutions. So these are the 2 pieces, or the 2 x values, where I would hit the x-axis. And when I ask you to solve by factoring or find the zeros of a quadratic equation, this is a process that we are going to use. And we're going to do one more of these together. So here's the next equation that we're going to deal with. Very first thing I need to check, does it have a greatest common factor? And in this case, it absolutely does. 8, 24, and 10 are all even numbers, so that tells me right off the bat I know I can at least factor out a 2. So I'm going to factor out 2 and find out what would be left over. So that would give me 4x squared plus 12x plus 5. And I'm going to use this now to start factoring, because my goal is to break it down into multiplication as simplified as it can be. So how can I get binomials out of this 4x squared plus 12x plus 5? I'm going to use this new equation as my values of a, b, and c. So when I go make my t-chart, I'm actually doing 4 times 5 on the left-hand side now, which is going to get me to 20. And then my goal is a value of 12 when I combine like terms. If you don't see it right off the bat, that's okay. List out all of your factors. So 1 times 20, 2 times 10, 4 times 5. See what happens when you break down the multiplication of it. Well, 1 plus 20, that would give me 21. That's not helpful. 10 plus 2 gets me 12, so that must be the ones that I need. So I don't even need to worry about the other factors that could have happened. So these are the two numbers that I'm going to take into the box. 4x squared is going to go first, plus 5 will be the last one, and then into the diagonals are going to be 2x and 10x. And just so there's no confusion, I'm going to just write this as 5. Now to get from the inside out, I'm looking for a greatest common factor, every row and every column. Across the top here, 4x squared and 2x, I can take out 2x. 10x and 5, can pull out a 5 there. Straight down this way, the numbers both have a 2 in common. I can pull x out of each of them. 2x and 5, they don't have anything in common at all, so I'm just going to put a 1. Now, if I'm thinking about this in terms of multiplication, the reason I put 1 here is 2x times 1 gets me back to where I started. 5 and 1 get me back to where I started. So if for some reason you find that they have nothing in common, that tells you that you need to use a 1. Or like in our last example, they had nothing in common but they were both negative, then I could take out the negative 1. So for this, my factors are going to be 2x plus 5 and 2x plus 1. But I still got this guy that I'm going to bring down as well, because that's my greatest common factor. I still needed him because this 2, when I multiply together, gets me back to the very beginning of 8x squared plus 24x plus 10. Excuse me. And since I'm looking for my zeros, I'm going to set the whole thing equal to 0 and figure out what values of x make the entire equation turn out to be 0. Now you'll notice that since I'm doing multiplication, this 2, although it is very important for the rest of my graph, for the zeros themselves, because I'm multiplying to get a value of 0, this 2 will not matter only when it comes to finding my zeros or the roots. Every other process, or every other step of the graphing process, this 2 will matter, but right now for the zeros it doesn't. So I'm going to take 2x plus 5 and find out what value of x would make this factor go to 0, and that would be x equals negative 5 halves. So that's one of them. The other one I'm going to say, well, what if 2x plus 1 is the piece that went to 0? That would have to be an x value of negative 1 half. So now this tells me that where the graph crosses the x-axis is at negative 5 halves and negative 1 half. If you leave these as fractions, that is totally fine by me. If you want to write them as a decimal, that's fine too. So this process I have factored, and then I used my factors to find my roots, or the zeros. And your mission is to do the same thing for both of these equations. And what we'll do in class tomorrow is go through the examples here, make sure everybody's on the same page, and use that with our catapult project.